Hello students. Under the course Database Management System, in module number 3, Relational Model and Relational Algebra, today we are going to study mapping the ER model to relational model. Mapping ER model, entity relationship model to the relational model. For this, we have referred following textbooks: Database Management System Concept, then Fundamentals of Database System, and third is Database Management Systems. The first step is to identify the case study for which we have to create the database. Here we are going to consider company database. So for this company database, this is the given problem statement. So in this problem statement, it is specified the various entities, the relationship among the entities, attributes of various entities, and the required data, what we want to access from that database that it is given in the problem statement. You can consider any other organizations for creation of the database like hospital management system or university management system, hotel management system, even library management system, tours and travels management system, college management system, any case study you can consider. So in the another example here, this is the another example of banking database management system problem statement. Okay. So in the previous video lecture, the lecture was on how to draw ER diagram for the company database. In that video, we have studied the various steps to draw an ER diagram for the given case study or for the given problem statements. So the first step include like first identify read the problem statement in detail, then identify all the strong entities and shown by the rectangles. So here you can see that employee, department, project, dependent, these are all the entities. Then we have to specify strong entities like employee, department, and project, and dependent is a weak entity, which is shown by the double rectangle. So the second step is to identify the weak entity, which is shown in the ER diagram by the double rectangle, and the relationship with the strong entity of this weak entity by the double diamond. This okay. Then the third step we can say that is to find the relationship between the various entities. Employee works for the department. Employee manages the department. So this is the relationship. So we have to identify how the relationship of this entity with the another entity, whether it is a relationship is a total participation or partial participation shown by double link and the single link, etc. So that from this given problem statement, we have to draw this ER diagram step by step. Okay. So the next step we have studied in that video is identify what is the relationship of this entity with the another entity with the cardinality ratio, whether the relationship is 1-to-1 relationship or whether it is many-to-one relationship or whether it is many-to-many relationship. So that is called as the cardinality ratio, or we can say that how many entities in this entity sets are involved in this relationship, whether it is many to many or one to many or one to one. Okay, so these also we have checked that various attributes which are required to specify, or we have to specify in the ER diagram, like composite attributes or key attributes or derived attribute or multi-valued attribute. Okay, so all these various attributes can be shown with the various notations like double oval, double dotted oval, or underline for the key attributes. Okay, if the superclass subclass relationship is there, like here in the another example, we can see that from this problem statement, we can see that here loan can be of two, sorry, accounts can be of two type. One is the saving account and second is the checking account. So if the superclass subclass relationship is there or inheritance is there, then which is given in the problem statement, then we in the ER diagram it is shown by the is a relationship or by using the disjoint D or overlapping concepts. Okay, so hope you all are aware of this concept, how to draw the ER diagram or ER diagram from the given problem statements. Okay, so now in this video lecture, we are going to study how to map this ER diagram or ER model into the relational model. So what are the rules to convert this ER and EER to relational schema or relational model? So we call it as a mapping rules or mapping algorithm. So there are total 7 steps to convert ER into relational mapping or relational schema. And there are 2 steps for conversion of ER to the relational schema. So what is the input? Input to our system is this ER diagram. So suppose this is the ER diagram for the company database. What will be the output of mapping after converting or after applying all these rules? What will be the output? First, see the output. Okay, after applying all these rules, this will be the output of our relational schema of company database. Schema, it means that what will be the relations, what will be the structure of our complete database, what will be the entities, whatever the entities we have seen, that entities now becomes the relation. Okay, this is called as the schema because this is a structure in which we can say that what are the attributes, what will be the primary key, foreign key, connectivity between the with these relations. So this is called as the relational schema or relational database schema. Another way to draw the relation schema is like this also. So in one of the textbook, you can draw the relation schema with the help of the name of the table, then the entities in which first is the primary key and other are connected with the other relations. So you can draw this way of relational database schema or you can draw this way of relational database schema. Now we'll see each and every step one by one. So first is mapping of regular entity type. Regular means strong entity. So in this diagram, whatever the regular entities we can see, what are the regular entities are there in this ER diagram? Employee, department, and project. These are all the regular entities or strong entities. So for that, we have to draw the relation schema. So relation, all these relations, strong entities becomes the relation. So how many are there? First is employee, then second is department, and third is project. Now write all the attributes which we have shown in the ER diagram. So social security number, name, gender, address, this composite attributes, everything you have to write. So social security number, SSN is the primary key, so underline it. Then first name, so write down F name. Then middle initial, then last name, then gender, then address. You can change the sequence, no problem, birth date and salary. So these are all the attributes we have to specify in the first step. So first 8 option is saying that whatever the regular entities, strong entities are there, for that create a relation schema. So department, in that department name or department number is a primary key. So we can consider department number, then department name, and department location. As department location is a multi-valued attribute, we have to apply another rule. So we cannot add here department location in the department relation. Similarly, project. So project number, if we consider as a primary key, then project number, project name, and project location. But I am writing here location because it is not a multi-valued attribute. It is a simple attribute. So in this way, option 8A is saying that mapping of regular entities. So for each regular entity E in the ER schema, create relation R. So we have to write down the relation R and include all the simple attributes. So whatever the attributes of this entity E, that attributes we have to add here. Then choose one of the key attribute of E as a primary key. So we can consider as social security number is the primary key of this employee if it is a employee entity. Or we can check, we can consider chosen the key of E as a composite. The set of simple attributes that form it will together form the primary key. It's not like that only one attribute can be a primary key, together can become a primary key of any of the table. For example, employee SSN and project number together can be formed as a primary key of this any of the table or relation. Second rule is mapping of weak entity type. So identify all the weak entities in your ER diagram. We know that how it is represented with the help of double diamond. So if the weak entity is present in the ER diagram or ER diagram, then consider that entity E. We know that in this entity diagram, the attributes are in which there is no primary key. So what will be the primary key of this weak entity? Weak entity or relation, whatever the relation we will create in this, if we don't have any key that is primary key, we have only the partial key which is denoted by the dotted line. Okay, for example, E1 if I am considering, so E1 is the partial key, then it is not sufficient. That time what we will do? We will take the help of strong entity which which has a relationship with the weak entity. So suppose this is the weak entity and the relationship is also weak entity. What we have to do? We have to take this E1 and this is E2. Then we have to take this primary key of this table, as a one of the attribute in this and make it as a primary key. So let's take the example of our company database. So again, go to the particular ER diagram. Here, dependent. Dependent is a weak entity. Dependent has a name. So for example, suppose a particular employee has two dependent, okay? Then how can we specify or identify that this dependent is for a particular employee? So for that, EMP dependent, if I am creating a new table EMP dependent or dependent, only dependent is a one this table or relation, then name is a partial key, then gender, then birth date, and then relationship. Okay, so the name of the dependent is not sufficient. So if I am saying that Amit is a boy, okay, and his relationship is son for a particular employee, or his father who is dependent on a particular employee. The dependent can be anyone. So then that time we cannot specify that this name and another name, for example, Amit is again there for another employee's dependent. Then we cannot differentiate that who is dependent on which employee. So for that, what we have to do for weak entity, we have to write consider the employee social security number. Okay, employee social security number as a one of the key attribute along with the name. And now you can see that this becomes the primary key of this together becomes the primary key of this table. So in this diagram, okay, so here it is saying that foreign key for each weak entity type W in ER schema with owner entity type E, create relation R and include all the simple attributes of the W as an attribute. Uh, W as an attribute of R. Also include as a foreign key attribute of R the primary key attribute of the relation. So here whatever I have added here, ESSN. ESSN is the foreign key. This is the foreign key which refers the primary key of this employee. So in this way there is a connection. Okay, this is for the second rule, weak entity. Next, mapping of binary one-to-one relation type. Okay, binary of one-to-one relation type. So see that wherever it is one-to-one relationship, is there any one-to-one relationship? Yes. Employee manages the department. One employee manage one department. So for this, how to make the relationship of employee and dependent? Always keep in mind that the relationship is always shown with the primary key, foreign key, integrity constraint. We also call it as a referential integrity that we have done here. That we have done here. So when employee manages the department, you can see in the ER diagram. I will show you in this diagram. Employee manages the department. So here in the department number, department name, department number is the primary key. Here it is considered MGR SSN. So what it is here, one of the attribute is added MGR SSN, who is the manager of the particular department, who manages the department, and manager start date. That attribute is added in the department, and social security number is the primary key in the employee table, which refers by the foreign key in this table. Okay. So we can see that the particular department, HR department, department number 1, who is the manager, MGR SSN. For example, employee 101 is the manager, so 101. And the start date 2023 23 4/20. So in this way you can write the date. So what here, if it is one-to-one, then there are 3 rules. Either you can create a single table. So the first, we have understood that foreign key approach. So add the primary key of one table as a refer key in the another table. So here MGR SSN is the one of the attribute which we have added, which refers the primary key of another table, that is SSN in the employee table. Next, MGR relation. Create only one relation. Do not create these 2 tables. One is the employee and second is the department. So create only one relation and you can add all the attributes of both the relation. An alternate mapping of one-to-one relation is possible by merging the 2 entity types and the relationship into a single relation. This may be appropriate when both the participation are total. If there is a total participation, then it is possible. And third is cross-reference. It means that what we have to do, we can create 3 relations. Okay. So one is employee table, another is department, and third relation you can say that EMP DEPT, in which add the primary key of both the tables as a reference key. So SSN and D number, which D number refers this D number of this table, department, and EMP SSN will refer this. So in this way, you can create 3 tables. So these are the three options, but the first option is mostly we refer to add the foreign key as a referential integrity with the another relation, which is referring the primary key of another table. Next. Hope that you are understanding the step 1, step 2, and step 3. Next is mapping of binary 1 to n relationship. 1 to n relationship means when there is a relationship with many to 1 to many. Now see in the ER diagram of company database. So many employees works in a particular department. So the rule is saying that when there is many side particular entity, okay, employee, many employees works in a particular department. So what we have to do, primary key of this side, okay, one side, that is number, can be added as a foreign key in the employee. So here we can, I will show you that employee in that, what I will add, DNO, department number, means a particular employee who is working in a department number. This department number is the primary key of this table, D number. So this is the primary key. So I can say that this is the connectivity with the DNO. So DNO is the primary key of this table. Okay, so many side we have to add this as a foreign. So this is a foreign key. This is the primary key because every department number is unique for each and every department. Understood? So for 1 to many, that is the rule. The next rule is related with many to many. Many employees works on many projects. So when there is a many to many relationship, then create three relation. One is the employee, which is already created. Another is project that we have created here as a strong entity. And for the works on, we have to create a new relation. So here I am writing the works on relation, WORKS, works on, the name of the relation, in which what will be the attributes? Attributes will be, these are the two entities which are involved in the relationship. So employee ka primary key SSN. So I can write here ESSN so that you will not be confused. And second is project ka PNO. So here instead of P number, I am writing project number. And what is this? The third attribute? Hours. It means that how many hours the particular employee is working on a particular project. So what will be the value of ESSN, which will come from this SSN? So primary key of this employee refers as a foreign key in works on. Similarly, project number. So project number is the primary key of this table, and this will be the foreign key. Sorry, here there should not be arrow. The arrow should denote to the primary key. So works on, in this relation, this SSN and PNO together become the primary key because both are the reference key or foreign key. So this is the rule for many to many. So that is given here in this rule, 1 to 1, many to many. Are you understanding? So you can read here for many to many. For each regular in binary many to many relationship in type R, create a new relation S to represent R. So for the relationship, we have to create a relation, and in which we have to add the foreign keys, which are, so two entities who are involved in this many to many relationship, E1 and E2, then this relationship, for this we have to create the relation schema. So here I have to create three little relations. One is for E1, one is for E2, and one is for R. And in the R, we have to add the foreign key as a primary key for E1 and foreign key as a primary key in E2. Okay. So here the primary key of this table and here will be the primary key of it. So in this way, we have to map the many to many relationship. Next is mapping of multi-valued attribute. So we have seen that many times in the entity, there is a multi-valued attribute. For example, suppose employee has phone number as a multi-valued attribute, which is denoted by double one. So for that, it's not possible to add this phone number in the employee relation along with the other attributes because other attribute has a single value. So employee name, employee social security number, salary, which is unique for the particular employee. So for this, we cannot add. So what we have to do? We have to create new relation. So here what I have to write, employee becomes the one of the relation in which all the attributes you can add except phone number. So what I am creating a new relation EMP phone and what I have to add social security number. We call it as maybe ESSN or maybe any other name you can give, which will refer the primary key of this table and phone number. Now why phone number is the multi-valued attribute. So for example, employee 101 has one of the phone number and same employee has another phone number. It is possible. That's why together becomes the primary key of this. So in this way, multi-value attribute you have to handle. The next is for mapping of n-ary relationship type. So for each n-ary relationship type R where n is greater than 2 means when more than two entities are involved in the relationship. So till this we have studied only two entities which are involved in the relationship, but there may be a number of entities who are involved in the relationship, ternary or many more. So in that case, what we have to do, for each n-ary relationship type R where n is greater than 2, create a new relation S to represent R. So what we have to do, we have to add this relationship, we have to convert this relationship into a binary relationship. So we can say that E1 is involved with R1 with E2 or E1 is involved with E1 is involved with relation R2 with E4 and so on. So we have to create a binary relationship with the. So include a foreign key attribute in S, the primary key of the relation that represent the participating entity type. Also include any simple attribute of another relationship type. So whatever the attributes are there in the relation, we can add to the relation. So these are all the rules. By applying these rules, we get complete relational schema. So here you can see that for many to many, we have added ESSN, PNO and hours. How many hours the employee working? Dependent. So ESSN is the foreign key, which refers the primary key of this employee table and dependent name is a partial key together becomes the primary key of this. Here multi-valued attribute which was the dependent location, department location. So department location, if it is a multi-valued attribute, then department 1 location Mumbai, department 1 location Bangalore, department 3 location. So here what will, although this will repeat, the locations will repeat for the same department, it is possible. So in this way, you have to apply all these rules to convert the ER into relational schema or relational database. Now we have to use the other rules, option number 8A for conversion of option of mapping of specialization or generalization if it is there in the diagram into the relational schema. And if union type is there in the or category, then we have to apply the step 9. Video we have studied the mapping the ER model into the relational model. So thank you, students. Thanks for watching this video. Please like, share, and subscribe this channel. Thanks a lot.